This is question number 22 in chapter 8. It reads, 55-kilogram person riding a bike puts all of her weight on each pedal when climbing a hill. The pedals rotate at in a circle radius 0.17 meters or 17 centimeters. What is the maximum torque she exerts, and how could she exert more torque? In this case, I've made a quick sketch of the girl. She is stepping here on the pedal, and she's putting this downwards force mg on the pedal, which is of course connected to the crank, which turns this gear and eventually to the rest of the bike. But the question is simply asking about the torque that she produces, and the maximum downwards force that she can produce is when she stands up on the bike and basically puts all of her weight downwards. So this force that she can apply in this case is mg when she puts all of her weight. And most of us have done this. You're climbing a hill, you get out of the saddle of the bike, and you stand up on the pedals in order to produce the most amount of torque. So tau is equal to F times D, where D is this lever arm distance. That's this distance here, which is your radius, how far you are from the axis of rotation, or what we've come to know as the lever arm. We could include sine theta, our trigonometric component here. However, as long as this is perpendicular, the angle between the application and the line of action of the force and the lever arm, it's 90 degrees, we're going to get 1. So we can either omit it entirely or just keep it there. And we also are going to recognize that the force that she produces is simply mg. So I get mg times this distance times 1 is equal to the maximum torque that she can produce. So she's got a mass of 55 kilograms. I'm going to multiply that by 9.8 meters per second squared. This is g times this distance of 0.17 meters. And when I do that, I get a maximum torque that she can produce of 92 Newton times meters, or Newton meters. So that first question, part A, is what's this maximum torque that she can produce? It's 92 meters. The answer to the second question is she could be pulling up with the other pedal, and by doing that she would be adding to the total torque. How do you do that? Typically when you have like cages over the top of pedals, I don't know if you've seen these on like mountain bikes, you'll see some sort of thing here. That cage over the toe allows you to pull up with one as you push down with the other, producing more torque. Also on higher end bikes you'll see clips, so there's some sort of mechanical attachment on the bottom here that either those cages or those clips pulling up with the other pedal would increase the amount of torque.